Hello, children. So, looking at May 18th to 22, looking at day 9. Today's tasks are as follows. So, your first thing to do today is to check the quiz grade if you haven't already. Hopefully, I released those to you already, so you should be able to see your quiz and see what you did wrong. Make sure you continue to practice those, as we will have another quiz at the end of this school year over this material. Next, you're going to watch this video, and then you have some homework to do. And then your final task is going to be to email me. You're only going to have this one video to watch this week, as you can see later, day 10 is a work day on your project. So I'll talk about that more after we go over this beginning stuff first. So we are going to go over some notes today. So before we get started, you will need your note sheet. So if you don't have that, make sure you grab that out. You'll also need a calculator. So today we're going to be looking at the combined gas law. And the combined gas law is basically an integration of pressure, volume, and temperature all into one formula. So, a definition. The combined gas law expresses the relationship between pressure, volume, and a temperature of a fixed amount of gas. So, as a reminder, temperature is always going to be in Kelvin. So make sure you have temperature in Kelvin. And nothing is going to be held constant in this except for the amount of gas. So we're not changing the amount of gas. We won't be changing that until next week. So I do have a quick little video to show you of how to solve a problem with the combined gas law. I wanted to show you this before I did a problem with you, just to show you a different way of how to solve the problem and how to do the math in case you're struggling with the actual algebra. So let's watch this together.
All right, in class you should have learned about the 3 different gas laws. The first one being Boyle's law, and it talks about the relationship between pressure and volume of a particular gas. The next one should be Charles' law, which talks about the volume and temperature of a particular gas. And the last one should be Gay-Lussac's law, which talks about the relationship between pressure and temperature of a particular gas. Okay, but what happens when you have pressure, volume, and temperature all changing? Well, we're actually going to combine these gas laws to form one giant gas law called the combined gas law. Okay, if you notice in these 3 gas laws, the pressure and volume are always on the numerator. So we're going to keep them on the numerator, P1, V1. And notice that temperature is in the denominator over T1. So all these things are just squished into one. And then P2, V2 over T2. Okay, so this is what we're going to call the combined gas law. So let's actually go over an example and do one together. All right, so I have a problem up here that says a gas at 110 kilopascals and 30 degrees Celsius fills a flexible container with an initial volume of 2 liters. Okay, if the temperature is raised to 80 degrees Celsius and the pressure increased to 440 kilopascals, what is the new volume? Okay, so notice we have 3 variables. We're talking about pressure, temperature, and volume. Okay, so now we're going to employ the combined gas law, dealing with all 3 of those variables. So we're going to look at our first number, 110 kilopascals, and that is a unit of pressure, so we know that's our P1. Our P1 is 110 kilopascals at 30 degrees Celsius. I don't like things in Celsius, so I'm going to change this to Kelvin. So I'm going to add 273 to that, which makes it 303 Kelvin. That's our temperature. And our initial volume was 2 liters, so I'm going to say V1 equals 2 liters. Okay, then I continue reading. If the temperature is raised to 80 degrees Celsius, again, we want it in Kelvin, so we're going to add 273, making it 353. So our T2 is 353 Kelvin. And the pressure increased to 440 kilopascals. The pressure, P2, is equal to 440 kilopascals, which I'm very happy that it kept it in kilopascals. So to make sure these units are the same, because pressure can be measured in several different units, we want to make sure our units are the same. And what is the new volume? So our V2 is our variable, what we're trying to find. Okay, so let's basically plug all these variables into our combined gas law to figure out what the new volume would be. Okay, so I'm going to erase this and say our pressure 1 is 110 kilopascals. Our volume 1 is 2 liters. Our temperature 1 is 303 Kelvin. Our pressure 2 is 440 kilopascals. We don't know our volume, so we're going to just say V2 over 353 Kelvin. Okay, when I'm looking for a variable, I'm going to cross multiply these guys. So I'm going to say 353 times 110 times 2, and that should give me 77660 if you put that in your calculator. So I just cross multiplied these guys. And then cross multiply these guys. 303 times 440 times V2 gives me 133320 V2. Okay, so then I want to isolate my variable. So I'm going to divide by 133320, 133320, and I find that my new volume is 0.58 liters. And that is how you do the combined gas law.
Alrighty, so in that video she showed how to derive the formula for the gas law. She talked about how in our normal equation we always have pressure on top and volume on top with temperature on bottom. So it's going to be the same with the combined gas law. We're going to have pressure 1 times volume 1 divided by temperature 1 equals P2 times V2 over T2. And as you could see in her video, she did some cross multiplying. I don't generally cross multiply, as that just doesn't make as much sense to me. But if cross multiplying makes sense to you, make sure you're solving like that and not using the format I'm about to show you. So we are going to go over a problem together. A helium-filled balloon has a volume of 50 liters at 25 degrees Celsius and 1.08 ATM. What volume will it have at 0.855 ATM and 10 degrees Celsius? So we're going to go over to our whiteboard and solve this together. Alrighty, so just like always, our first step is going to be to write down our variables, write down what we're dealing with. So it tells us a helium-filled balloon has a volume of 50 liters. So our volume 1, oh, a little too high, let me move it, equals 50 liters. It tells us at 25 degrees Celsius, so our temperature 1 is 25 degrees Celsius, and our pressure 1 is 1.08 ATM. It then tells us what volume will you have, so our volume 2 is X, at a temperature of 10 degrees Celsius, and a pressure, oh sorry, this is temperature 2, pressure 2, of 0.855. Now, we need to make sure our units are all the same. We have liters here, so we're going to be looking for liters here. We have Celsius and Celsius, which we know we cannot use Celsius. We need to convert those to kelvins. So to convert to Kelvin, remember, we do Celsius plus 273. So 273 plus 25 will give us 298 Kelvin and 283 Kelvin. And as you can see, we have ATM for pressure 1 and ATM for pressure 2, so we can leave those in ATM. So we're now going to plug into our formula. Remember, our formula is P1 V1 over T1 equals P2 V2 over T2. So we're just going to plug into our formula like we did before. So we're going to have 50 V1 times 1.08 divided by 298 Kelvin. Make sure you're using this 298 number. And that is going to be equal to 0.855x divided by 283. In order to solve this, we first need to solve this section. So we're going to do 50 times 108 divided by 298, which will give us 0.1812. And that's still going to be equal to this. Our first step here is we can see we have a number on our denominator. In order to get rid of that, we're going to multiply by that on both sides. So times 283. And that is going to give us 51.28 is equal to 0.855x. Since we're multiplying here, to get rid of it, we're going to divide. So divide by 0.855 on both sides to give us our final answer of x equals 59.98 liters. That's an 8. 59.98 liters is our answer. So that is how you solve for the combined gas law. Make sure if you have more questions on that, you take a look at the extra video section. There's some more examples in there also. So that is all the notes we're going to go over today. And now you do have some practice problems for homework. So if you go back into Google Classroom, you could see that your Day 9 combined gas law homework is here. If we open that up, I think it's about 8 questions. 7 questions about combined gas law. Again, it shouldn't take you very long. So after that, your next task then on your daily tasks is after you finish your homework, make sure you turn that in. It is due on Wednesday before midnight. I want you to start working on your final project, okay? Sometime this week, you need to email me to let me know how you're doing on that project and what help you need, because that project is due on Monday, okay? You need to have that project turned in by Monday. Remember, you are going to turn it in up at the top under Online Work Overview. It says Final Project, turn in here. You're going to turn the project in right here. Okay, so make sure that's complete and ready to go by Monday. But I do want you to email me letting me know how far you are. I need you to tell me your progress. So that'll be Day 9. For Day 10 this week, I am going to go over that right now as well. This whole day is to work on your project. If you have questions, you need to email me as soon as possible. So your only task today is to work on that project. So all you have to do today, this week is the combined gas law, email me, and work on this project. Along with that, you do need to sign up for a time to present your project. You aren't just going to be submitting these, you are going to be presenting them to me and a couple other classmates just to explain what you learned over the course of your project. In order to sign up for a time, you're going to click this document here, and it'll bring you to this. So you're going to use this table below to sign up for a time to present your project. Up to 8 different students can be presenting at one time. And we're going to do this via Zoom, so I'm going to post some links here, and those will be the links that you'll use to join our Zoom meeting. So let's say Tuesday, May 26th at 11 works for you. You just type your name into the box, and that's when you'll be presenting. Okay, so then maybe another student wants to present at that time, they'll put their name under student 2, and so forth. So make sure you start signing up for a time to present, and make sure you do that sooner rather than later to ensure you get a time that works best for you. If none of these times work for you, you need to reach out to me as soon as possible so that we can set up a time to present, because presenting is part of your grade. If you do not present your project, you will not get a grade on your project. So make sure you reach out to me if none of those times work so we can set up a separate time for you. That should be the end of this video. Again, if you have any questions, make sure you reach out. Hope you're all having a great day. Bye.